Hello class, my name is Dr. Carl Leptamendi and this is a review of Chapter 2 from the Business Mathematics text, 10th edition by Cleaves, Hobbs, and Noble. This PowerPoint presentation has a good number of slides, so for the purposes of keeping the video short, I'm going to try to go a little fast. And as always, if you have any questions, you want to review something or practice and one of the one of the examples, you can always feel free to pause the video. So there are 5 learning outcomes here. You will identify the types of fractions, convert an improper fraction to a whole number or mixed number, convert a whole number or mixed number to an improper fraction, reduce a fraction to lowest terms, and raise a fraction to higher terms. In identifying the types of fractions, a fraction is used to identify parts of a whole. It describes the relationship between the part and the whole. And as an example, in the figure below, there's a, if you can imagine that this is like a board, and you cut it into 4 equal parts. One of the sections are shaded white, or 1 out of 4, which is 1 over 4, so a quarter or a fourth, right? So if these two were shaded in, it would out of 2 equal parts, it would be 1 out of 2 parts, or half. The denominator is the number appearing below the fraction line. The numerator is the number that's above. The fraction line is a horizontal line, so then that's the fraction line. This is the numerator, and then this is the denominator. Okay? Numerator, denominator, fraction line. A proper fraction is a fraction with a value less than 1. So that's whenever you see that the top number is smaller than the bottom number, that's a proper fraction. An improper fraction is the inverse, and we'll get to that. So again, looking at 2/3, 2 is the numerator, 3 is the denominator. It is a proper fraction because this number is less than 1. If you try to make this division on the calculator, you'll see that it is less than 1. It should give you a decimal. And it is a proper fraction. The smaller number is on the top, larger number on the bottom. So in identifying this fraction, what part of the shaded area is blue? So as we can tell, there are 1, 2, 3 areas that are shaded blue out of 4 total. So it's 3/4, 3 out of 4. As another example, we have here 1, 2, 3 shaded out of 4, 5, 6, 7. So that's 3 out of 7 shaded. The numerator is greater than or equal to the denominator in an improper fraction. Therefore, the fraction is greater than or equal to 1. So then, just a quick tip, if, like I said before, if the numerator or the number above is bigger than the denominator, then it's an improper fraction. If the number on top is smaller than the number on the bottom, it's a proper fraction. So then if we look at this, the bigger number is on the bottom, so it is an improper fraction. See, so improper, proper, improper. Converting an improper fraction to a mixed or whole number, divide the numerator of the improper fraction by the denominator. So divide the top number by the bottom number. If the remainder is 0, then the quotient or the answer is a whole number. If the remainder is not 0, the improper fraction will be expressed as a mixed number. So here are some examples. 120 over 10, this is an improper fraction. You divide 10 into 120, and it gives you 12. Again, this is another improper, 119 over 3. 3 into 119 equals 39 times, and then you have a remainder. So then that's what this is alluding to. And 4 goes into 135 33 times with a remainder also. Converting a whole or mixed number into an improper fraction, you multiply the denominator, so the bottom number, of the mixed number by the whole number part. Add the product from the previous step to the numerator of the mixed number. This is the numerator of the improper fraction. Use the denominator of the mixed number as the denominator of the improper fraction. So in all those words, basically what it meant to say is this. So it's asking you to convert 10 and 3/4 to an improper fraction. So what you do is you take this 4 and then you multiply it by 10, which gives you 40, right? It's hard to write on the trackpad. And then that should go over 4. So let's see how they solved it. The numerator of the fraction is 3. Oh, so you have to add, so 4 times 10 is 40, and then you add the 3. So then that's the step. Bottom number times the big number plus the top number, and then you leave the bottom number as is unless you can't convert even further, then you recheck your work. The numerator of the fraction is 3. Multiply the whole number, which is 10, by the denominator, which is 4. The result is 40. And then you add the numerator, which is the top number, to the answer here, and it's 43. And then you keep the denominator, so the answer is 43 over 4. Reducing a fraction to lowest terms. Inspect the numerator and the denominator to find any whole number by which both can be evenly divided. Carry out the operation until there's no one number that both can be evenly divided by. So as a tip, you can check if the denominator can be divided by the numerator. 3 over 15 can be reduced to 1 over 5 because 3 goes into 3 one time and 3 goes into 15 5 times. Reducing examples to lowest terms, a tip, check if the numerator can be divided by the denominator. So then that's checking if this number here can be divided by the bottom number here. So then in this example, yes, you can do that, and then it reduces to 3 over 5. In the second example, 27 over 63, this can be reduced to 3 over 7. And 21 over 147 can be reduced to 1 over 7. And the textbook does a pretty good job in section 2.1 of explaining the process. So make sure that you also review it. If you're following along with the suggested schedule that I gave you in the beginning of the class, then this week you should be reading chapter 2 and working on your chapter 2 deliverables in my math lab. Finding the greatest common divisor of two numbers. The most direct way to reduce a fraction to lowest terms is to use the greatest common denominator. The greatest common denominator is the largest number by which the denominator and numerator can be evenly divided. So as an example, the greatest common denominator of 15 and 20 is 5. Any number greater than 5 would result in a quotient with a remainder. So that just means that the number 5 is the biggest number that will fit into 15 and 20 evenly. Find the greatest common denominator of 42 and 48. I'm sorry, 28. Divide the larger number by the smaller number. So 42 divided by 28 is equal to 1 because it fits one whole time with a remainder of 14. Divide the divisor, which is the 28, by the remainder of the previous operation, so into 14. And then you have 2, remainder 0. When the remainder equals 0, the divisor from that operation, which is 14 in this case, is the greatest common denominator. So then here are some more examples. Finding the greatest common denominator of 30 and 36. The greatest common denominator is 6. 30 and 125 is 5. And 17 and 51 comes out to 17. Raising a fraction to higher terms. The question posed is 3/4 equals to blank over 8. Divide the two denominators. 4 goes, just this one, goes into 8 2 times. So when you take the 2, multiply 3, which is this 3 up here, times this 2 to get the equivalent numerator. So you get 6. So then the 6 is what would go up here. And then you'll multiply 4 by 2, again this number here, to get the equivalent denominator. So it's 8, because, and you confirm that it's right because 4 times 2 is 8. Here are some examples. Determine the equivalent fraction in higher terms. So 4/5 is equal to, and then you can tell from here, for example, from 5 to get to 25, what do? You have to multiply something. 5 times 5 is 25. So then what you do to the bottom, you also do to the top. And the answer is 20 over 25. For the next one, 7 over 8 equals, and if you'd like to try it out, you can pause it. The answer is 35 over 40. Because what they do here, 8 times something, which is this, 5, equals 40. And then you do the same to the top. Next one, 3 over 5 equals, and if you'd like to try it out, you can pause now. And the answer is 36 over 60. And what it looks like they did here is from 5 to 60, from 5 to get to 60 is you multiply it by 12. And then what you do to the bottom, you must also do to the top. So if you multiply 3 times 12, you get 36. Section 2-2, the learning outcomes of this section are to add fractions with like denominators, find the least common denominator for 2 or more fractions, add fractions and mixed numbers, subtract fractions and mixed numbers. So for the first part of section 2.2, we're going to add the numerators. The denominators remain the same, and if necessary, convert an improper fraction to a mixed number. So as an example, we have 1 over 4, 3 over 4, and 1 over 4. So then the denominators are the same. You just add the top. So then if you can see here, they just move this 4 right over. Right? 1 plus 3 is 4, plus 1 is 5. So then this comes out to be 4 over 5, but you have to convert it to a mixed number. 4 goes into 5 one time. The remainder of 1, you keep the denominator the same. Adding fractions with different denominators. First, find the least common denominator, LCD. The LCD is the smallest number that can be divided evenly by each original denominator. The common denominator can sometimes be found by inspection, mentally selecting a number that can be evenly divided by the denominator. So you do this through trial and error. So for example, find the lowest common denominator for 3 over 4 and 5 over 8. Convert 3 over 4 to an equivalent fraction in eighths, and then add 2 fractions together. It is not apparent which number might be the lowest common denominator given different denominators, such as 12 and 30. So a tip that's provided by the textbook is that you can use prime numbers to find the lowest common denominator. And just a refresher, a prime number is a number that's greater than 1, and that can be divided evenly by itself and 1. So here are the first 10 prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Finding the least common denominator for 2 or more fractions. So the question here, the exercise is find the lowest common denominator of 7/12 and 11/30. The first step is to write the denominators in a row. So then you have 12 and 30, which is obtained from here. The second step is to divide each one by the smallest prime number by which any of the numbers can be evenly divided. So then what they do here is 12 divided by 2, which is 6. 30 divided by 2 is 15. So they took the smallest prime number, and you can just go back to that list of the first set of prime numbers and test it that way. The third step is to write a new row of numbers using the quotients from step 1. And right here we got 6 and 15 from here. You see? Any numbers in the first row that cannot be evenly divided by the first prime number. The fourth step, divide again by the smallest prime number by which any of the numbers can be evenly divided. So then we're looking at the two numbers 6 and 15. 6 divided by 2 is 3. Bring down the 15. Divide again by the smallest prime number by which any of the numbers can be evenly divided. The fifth step then is to continue this process until you have a row of ones. In step 6, you multiply all the prime numbers used to divide the denominators. All the prime numbers. The product is the least common denominator. So the LCD, and as you recall, the numbers that were used here, we have 2, 2, 3, and 5. And then those were also the numbers that were utilized here in the problem. And if you have any further questions, or after you've read section 2.2 you still have any outstanding issues with the processes, you can always send me an email and I'll be happy to help you in any of the problems if you need additional guidance. Find the least common denominator for 2 or more fractions. So the question posed here is add the fractions: 4 over 5, 1 over 2, and 1 over 8. The first step is to find the lowest common denominator. Multiply the prime numbers from the list, from the first column, 2 times 2 times 2 times 5, from here, to get the lowest common denominator. And the lowest common denominator is 40. 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40. Convert the fractions to the equivalent using 40 as the denominator. 4 over 5 becomes 32 over 40. 1 over 2 becomes 20 over 40. And 1 over 8 becomes 5 over 40. So this is all using 40 as the denominator. So you see 40 here at the bottom. 32 over 40, 20 over 40, and 5 over 40 equals 57 over 40. So this is an improper fraction, right? Because the top number is larger than the bottom. So then you use the process of 40 goes into 57 one whole time. 2 is too many, with a remainder, and you keep the bottom number the same. The third part of section 2.2, adding fractions and mixed numbers. Add the whole number parts. Add the fraction parts and reduce to lowest terms. Change improper fractions to whole or mixed numbers. Add the whole number parts. So for the first step, you have 10 and 1/8 minus 7 1/2. You want to convert the fraction portion of each mixed number to equivalent fractions. Step 2, borrow 1 from the whole number to carry out the operation, and then reduce the lowest terms if necessary. So then you have, in step 2, you have 10 and 1/8 converted to 9 and 9/8. 7 and 4/8 stays the same, but then now you have the denominators equal. They're the same now. And then if you do the operation, 9 minus 7 is 2, 9 minus 4 is 5, denominator stays the same. Subtracting fractions with like denominators. Subtract the smaller numerator from the greater one, the denominator remains the same. So 5 minus 3 is 2, denominator stays the same, so you carry that over. And then 2 over 8 is equivalent to 1 over 4, and that's reducing if necessary. So then I guess when you're looking at these problems, an easy thing to do if the denominators are the same is to just kind of like put a box over the numerators. 5 minus 3 is 2, and then you, with the numerator, with the denominator rather, if they remain the same, all you do is just bring it over. So then that way you're not, you don't mix the steps. Subtracting fractions with different denominators. Just like in addition, to subtract fractions, you must have a common denominator. Use the same methods of inspection or prime numbers to determine the lowest common denominator. So you can carry out the operation, reduce to lowest terms as needed. So 5 over 12 minus 1 over 3 equals. The first step is to find the lowest common denominator, which is 12 in this situation. So now you want to change 1 over 3 to an equivalent fraction, because we want to get the denominator to be 12. So then in this situation, to get there, 3 times 4 is 12, 1 times 4 is 4. Carry out the operation and reduce to lowest terms if needed. So again, remember that box that I told you about? You just put it right over here because the denominators are the same, 12 and 12. 5 minus 4 is 1, and then you just move the denominator right over. Okay? You do not do 12 minus 12. And that's an error that I see a lot of people make, that they try to move forward with an operation using the same denominators. So here are some examples if you'd like to try it out on your own. 7 over 8 minus 2 over 3 equals. And remember, we have to make the denominators the same. And you can pause it now, pause the video now if you'd like to try it on your own. The answer is 5 over 24. The next example, 2 over 3 minus 1 over 5 equals, and you can pause the video now if you'd like to try it on your own. And the answer is 7 over 15. And lastly, 4 over 5 minus 1 over 6 equals, and feel free to pause now. The answer is 19 over 30. So here's a word problem using fractions. Maria has 6 1/8 cup of flour, but only needs 4 1/4 cups for her recipe. How much will she have left? And the answer is 1 cup and 7/8. went ahead there. As another example, Julia needs 3 2/3 of yards of tape to finish a display. Bob brought her a 5 7/8 yard piece from the supply room. How much will be left? So here you know that you're subtracting the two. So remember, the process is to make sure that the denominator are equivalent. And if you'd like to pause the video now, you can do so. The answer is 2 and 5/24. Learning outcomes for the third part of Chapter 2, multiply fractions and mixed numbers, divide fractions and mixed numbers. Multiplying fractions and mixed numbers. To multiply two fractions, find the numerator of the product by multiplying the numerator of the fractions. So then it's a little different than adding and subtracting. Here, 1 times 7 is 7, and then you do it to the bottom. 3 times 8 is 24. And then you reduce to lowest terms if necessary. So then, can you reduce this to lowest terms? No, you can't. It would be different if it were, like 5/25. You can reduce that, but not 7/24. A tip is to keep things simple if possible. Reduce before multiplying. The 3 in the denominator in the first fraction and 3 in the numerator of the second cancel each other out and become 1. So they're talking about this here, these two 3's. And then it becomes 1/4. And the reason for that is because if you do it the other way, for example, 1 times 3 is 3, 3 times 4 is 12, and when you reduce this, it's going to reduce to 1/4 anyways. Okay, so it's just a little trick. Multiply mixed numbers and whole numbers. Write the mixed numbers and whole numbers as improper fractions. Reduce numerators and denominators as appropriate and multiply the fractions. Reduce to lowest terms and or write as a whole number or mixed number. So now here we have the example 1 and 2/3 times 3 and 3/4. So now what they did here was 3 times 1 is 3 plus 2 is 5. You move the 3 over. 4 times 3 is 12 plus 3 is 15. Move the 4 over. So now the new question that you're looking at is 5/3 times 15/4. So you're going to do 5 times 15. That's going to be your top number. 3 times 4 is going to be your bottom number. The 3 can be reduced to a 1 and the 15 to a 5 before multiplying. So the product of this is 25/4, and then you convert to a mixed number. Or you can do it also how how I was saying too, the 5 times 15 and then the 3 times 4, and then you can convert that to a mixed number as well. Are products always larger than their factors? No. When the multiplier is a proper fraction, the product is less than the original number. So here, 5 times 3/5 equals 3 is the example. This is also true when the multiplicand is a whole number, fraction, or mixed number. So 2 and 1/2 times half equals 1 1/4. The relationship between multiplying and dividing fractions involves a concept called reciprocals. Two numbers are reciprocals if their product equals 1. So 2 is a reciprocal of half. And the reason for that is whenever you see a whole number on its own, it's basically the same as saying 2/1. So then 2/1 flipped is 1/2. What is the reciprocal of 1/3? And the reciprocal is 3, because 1/3 is a reciprocal. I always think that it's flipping the number. is 3 over 1, which equals 3. Divide fractions or mixed numbers. Write the numbers as fractions. Find the reciprocal of the divisor. Multiply the dividend by the reciprocal of the divisor. Reduce to lowest terms and or write as a whole or mixed number. So for example, you have 3 1/4 divided by 2 over 3. The first step is to convert 3 1/4 to an improper fraction. So you do 4 times 3, which is 12, plus 1 is 13, and then bring over the 4. Change 2 over 3 to its reciprocal, which is 3 over 2. So you're just flipping this over 3 over 2. And then change from division to multiplication. So now you have 3 over 4 and 3 over 2. So then that's what this becomes here. And then multiply. 13 times 3 is 39. Oh, sorry. 3 times 13 is 39. 4 times 2 is 8. And then you work it out, you get 4 and 7 over 8 after you convert that to a mixed number from an improper fraction. Madison Duke makes appliques. A customer has ordered 5 appliques. Madison has 3/4 yard of fabric, and each applique uses 1/6 of a yard. Does she need more fabric? 3 over 4 divided by 1/6 becomes 3 over 4 times 6, and that's because we do the reciprocal of this, which is 6 over 1, which is the same as 6. And then you simplify by dividing 4 and 6 by 2. So 3 over 2 times 3. The answer is 4 and 7/8. She can only make 4. She needs more fabric. Another example, a home goods store is stacking decorative boxes on shelves. Each box is 4 2/3 inches tall. Shelf space is 45 inches. How many boxes will fit on each shelf? And the answer is 6. And this concludes the presentation for Chapter 2, Review of Fractions. As always, if you have any questions, please feel free to email me and I'll be more than happy to assist. Thanks and have a great day.